Hello, my students. This is P. Venkateshwarlu, PGT Physics, Dinandal Public School. Yesterday, we have already discussed the complete derivation of elastic collision. Okay, in that we have derived the relative velocity of approaches is equal to the relative velocity of separation or after collision. Okay, so in this case we can get final formula or final velocities from the last derivation. Okay, v1 is equal to m1 minus m2 by m1 plus m2 u1 plus 2m2 divided by m1 plus m2 into u2. Next, v2 2m1 divided by m1 plus m2 u1 plus m2 minus m1 divided by m1 plus m2 u2. These are the final equations of derivation. Okay, so here we know that everything in the derivation. Okay, see here, these are the final velocities. Okay, here we can have special cases. Special cases means what's that? Means case 1, m1 is equal to m2. m1 is equal to m2. Okay, m1 is equal to m2 means both colliding bodies having same mass. Both bodies having same mass. What happened? Okay, now we will check. So this m1, m2, m1 is equal to m2 can substitute in this equation. Understand? Okay, so v1 is equal to 0 plus 2m2 divided by 2m2 into u2. Okay, gets cancelled. v1 is equal to u2. v1 is equal to u2. Next, v2 is equal to 2m1 divided by 2m1 u1 plus 0. How it becomes 0? Both having same mass. The condition is both are maintaining same mass. So mass minus mass 0. Okay, so 2m1 gets cancelled. v2 is equal to u1. Okay, understand? See here, if the colliding bodies having same mass means they are interchange their velocities. After collision, they are interchange their velocities. Means here, the final velocity of the first body is equal to initial velocity of the second body. Okay, final velocity of the second body is equal to initial velocity of the first body. Okay, so if in colliding situation both are maintaining same mass means in that case what happen? Interchange their velocities or exchange their velocities. Understand, my children? Yes. Next here m1 is very less than m2. m1 is very less than m2. Okay, the condition is case 2 m1 is very less than m2, then u2 becomes 0. Okay, understand? Means here a small body is colliding with a heavier body. Okay, that is the situation. What happened? We can see. Understand? So then V1 is equal to M1 is very less than M2. M2 means here minus M2 here by M1 is negligible, M1 is negligible, then U1 plus 2M2 by M1 plus M2, U2 value 0. Be careful, my dear children. So you can go through this. Directly I can apply in this situation. Okay, here in this case M1 approaches to 0. M1 nearly equal to 0 because M1 is very less than M2. M2 gets cancelled. V1 is equal to minus U1. V1 is equal to minus U1. Understand? Because U2 value 0. Understand? See here what happened. This is the example for consider a rubber ball. You can throw towards wall. So what happened? With the same velocity, it will back. Understand? So initial velocity, it becomes final velocity in opposite direction. Be careful, my children. If their mass is equal, means their velocities are interchanged. If their mass is equal, after this you can write, if their velocities, if their masses are equal, means their velocities are interchange. Understand? Interchange. Here in this case the example is consider a ball. So this is M2, this is M1, this is U2 becomes 0, U1. Understand? So here when the body colliding with the wall, what happened? With the same velocity it will get bouncing back. That's why V2 is equal to minus U1. V2 is equal to minus U1 means when a ball thrown towards wall means the ball come back with the opposite direction. First one direction is towards left. Second one direction is right. So minus indicates opposite direction. Understand, my children? So this is about case 1 and case 2 in elastic collision. Next one, my children, perfectly inelastic collision. Perfectly inelastic collision. Perfectly inelastic collision. So what is the definition of perfectly inelastic collision? So coming to the definition of perfectly inelastic collision, we know that collision, a strong interaction between the two colliding bodies, after that their momentum or interchange or their momentum is conserved or redistribution. See here, so after colliding, two or more bodies are colliding with each other. So after collision, both both bodies stick together. Both bodies are stick together means what happened? Their final velocity is same. After collision they are moving with same velocity. Understand, my children? So if two bodies are colliding, after that these two bodies are moving with the same velocity. When two bodies stick together after collision, the collision is said to be perfectly elastic collision. See here, consider an example bullet. Consider bullet and target. Bullet fired from the gun. So bullet and target moving with the same velocity, stick together. See here, according to the definition, if two bodies are colliding each other, after collision these two bodies are moving with the same velocity. This type of collision we can say perfectly inelastic collision. So in this situation, the kinetic energy is positive value, means which converted into like heat energy, light energy and sound energy. Understand? Coming to derivation. See here, so this is a straight line. Consider two bodies m1, which is move u1. Next m2 body. U2 becomes 0. Understand? U2 becomes 0, my dear children. Understand? This is the main condition. Means which is rest. So consider a mass m1, velocity u1. Consider another mass m2, velocity is u2, means rest. So both are colliding each other, m1 and m2. After collision these two bodies stick together, moving with the same velocity. Understand here, two bodies. So the first body having v1 velocity. So when v1 velocity is there, the object or the body moves towards the m2. Collision takes place. After collision these two bodies are moving with the same velocity. Understand? So this type of collision we can say perfectly inelastic collision, my dear children. Perfectly inelastic collision. Understand, my dear children? Yes. See, coming to the derivation, my dear children. Coming to derivation. So for derivation we need diagram. m1, m2, u1, u2 becomes 0, which is rest. After collision these two bodies are moving with same velocity, that is v, my dear children. Before, after collision. So we have to find their velocity and kinetic energy. So according to conservation of linear momentum. So the net momentum before the collision is equal to the net momentum after the collision. Momentum of the first body m1 u1 plus momentum of the second body m2 m2 0. Okay, is equal to m1, the momentum of the after collision. m1, what is the velocity? V plus m2, what is the velocity? V. Okay, we can write m1 u1 is equal to m1, v is common, m2 v is equal to what, Nana? m1 u1 by m1 plus m2. So this is the final velocity of the two bodies which are moving with the same velocity. Okay, so this is the velocity after collision. They are stick together. Understand? How we can find the change in kinetic energy? How we can find the change in kinetic energy? This is equation 1. So according to conservation of kinetic energy initial. Okay, so kinetic energy initial means 1 by 2 mass velocity square plus 1 by 2 mass velocity square, means which is rest. This is at rest. Okay, so rearrange this. ke1 is equal to 1 by 2 m1 u1 square plus 0. Okay, finally ke1 is equal to 1 by 2 m1 u1 square. Okay, this is equation 2. Understand? That is equation 2, my dear children. Okay, next kinetic energy final. ke2 means kinetic energy final. Yes, 1 by 2 m1 v square plus 1 by 2 m1 v square. V square is common. Rearrange this. 1 by 2 m1 plus m2 v square. Understand, my dear children? Understand? Yes. Okay, so V is what, Nana? V is what? m1 u1 by m1 plus m2. Okay, this is equation 3. Understand? From equation 1 and 3. Okay, ke2 is equal to 1 by 2 m1 plus m2. Okay, v square is there. Okay, v square is there, Nana. Instead of v, you can substitute this. Be careful. m1 u1 divided by m1 plus m2 whole square. Understand? So by cancelling, we can get here 1. Rearrange this 1 by 2 m1 square into u1 square divided by m1 plus m2. This is equation 4. My children. Okay, so now we can find the change in kinetic energy. Okay, so be careful, my children. Note down clearly. Okay, understand? So once again, so we know that perfectly inelastic collision means after collision the two bodies are moving with the same velocity. According to conservation of linear momentum, the net momentum before the collision is equal to the net momentum after the collision. So according to that, their momentum initial, their momentum final. Okay, finally they are moving same velocity. That velocity v is equal to m1 plus u1 by m1 plus m2. Okay, next, according to conservation of kinetic energy, the kinetic energy before the collision. Okay, kinetic energy of the first body, kinetic energy of the second body. Second body velocity 0. That's why we can take 0. Okay, after that we can get kinetic energy of the before the collision or first body 1 by 2 m1 u1 square. Okay, so like that kinetic energy after collision. Okay, so they are moving with the same velocity. That's why v square. So rearrange that, we can get 1 by 2 m1 plus m2 v square. Equation 3. Equation 3 and equation 1. We can get rearranged it by cancelling 1 by 2 m1 square u1 square divided by m1 plus m2. Okay. So how we can find change in kinetic energy? Change in kinetic energy means kinetic energy initial and kinetic energy final. Kinetic energy initial and kinetic energy final. Okay. Ke2. Okay. So change in kinetic energy delta Ke. Delta Ke is equal to Ke1 minus Ke2. Kinetic energy before the collision is equal to kinetic energy after the collision. Okay. See here. Yes, delta Ke is equal to Ke1. This is Ke1. 1 by 2 m1 u1 square minus 1 by 2 m1 square u1 square divided by m1 plus m2. m1 plus m2. Understand, my children? So rearrange this. Okay, 1 by 2 is common. 1 by 2 is common. Here u1 square is common. Okay, so remaining m1 plus m1 minus m1 square divided by m1 plus m2. Okay, understand? Yes, rearrange this. Rearrange this, my children. Rearrange this. 1 by 2 u1 square m1 plus m2 minus m1 square divided by m1 plus m2. Okay, understand? Understand, my children? Okay, 1 by 2 u1 square m1 into m1 square plus m1 m2 minus m1 square divided by m1 plus m2. m1 square minus m1 square gets cancelled. We can get rearrange this 1 by 2 u1 square into m1 m2 divided by m1 plus m2. Rearrange this, we can get 1 by 2 m1 m2 divided by m1 plus m2 into u1 square. Understand? This is equation 2, 3, 5. This is equation 5. Equation 5, my children. Okay, what is that? What is that? Yes, delta Ke is equal to 1 by 2 m1 m2 divided by m1 plus m2 u1 square. Understand? So this is the final equation. This is the final equation. This delta Ke is always positive. This delta Ke is always positive. Understand? Understand, my children? This change in kinetic energy in the form of positive, okay, which is converted into heat energy, light energy, and sound energy. My children. Okay, so this is the complete derivation of perfectly inelastic collision, and in this session we have already discussed with case 1, case 2 from the elastic collision.